Today we're going to discuss probability. Probability measures how likely it is for an event to occur. You can write probability as a fraction, decimal, or a percent. The probability of an event is a value between 0 and 0 would stand for 0%, which would mean it's impossible, and 1. 1 stands for when it's certain it will definitely happen, and it would be 100%. So it will be between 0 and 1. So between impossible and definitely going to happen. You might also remember that probability we have multiple types of probability. The first type we're going to talk about is experimental probability. This is based on actual data. So the probability of some event happening is the number of times the event occurs divided by the number of trials that you have. Or a shorthand way, and this is the way I remember it, the number of successes divided by the number of trials. Okay, now being experimental probability, it has to be based on actual data. So something that's actually happening or has happened. So in a parking lot we have 60 vehicles, 15 of them are trucks. What is the probability that a randomly selected vehicle is a truck? So we want to know what is the probability that a randomly selected vehicle is a truck. Well, since we have a parking lot that actually has 15 trucks and 60 vehicles, and we want a truck, the success would be the number of trucks, and the total would be the number of total vehicles, so 60. So that's our fraction. 15 and 60 can both be simplified. If I simplify that, I'll get 1/4. So that's my fraction. We also can write it as a decimal, 0.25, or we can write it as a percent, 25%. So those three ways are the three ways that it's acceptable to write probability. What if I wanted to know what is the probability of picking a vehicle that's not a truck? Okay, so we know there are still 60 total vehicles in the parking lot, and we know 15 of them are trucks. So if I have 60 total and 15 are trucks, how many would be not trucks? Well, the other 45. So again, we can simplify this. 3/4, 0.75 as a decimal, or 75%. And your sample space on this one is the total vehicles, or the trucks, and the not trucks. Okay, so sample space is what we're going to talk about next. The sample space is the set of all possible outcomes. So when each outcome in a sample space has the same probability, the outcomes are equally likely. So this happens in like a flip of a coin. In a flip of a coin, you have two options. You have heads and you have tails, And as long as your coin is not weighted or anything crazy, those are both equally likely. You also have this in like the roll of a dice. One die, sorry. You could get 1, 2, 3, 4, 5, or 6 from a roll of a standard die. And all of those are equally likely. So when we have these events, we can use theoretical probability. Now this is probability that's not based on something that's actually happened. It's based on what we think would happen when we have equally likely events. So if I have some sample space over here. So here's my sample space. So whatever I'm talking about. And I have an event A. And then I have some other event. And some other event. And some other event. I've got 4 events, only one of them is A. So, if I've got M total outcomes for my event A, so really I only have 1, then I have N total outcomes in the entire sample space. What do you think my theoretical probability would be? Well, it'd be the event I want to happen, so this one, divided by all of them. So how many possibilities are there? It looks like there's 4 events. So it would be 1 out of all 4 total. So what is the probability of event A occurring? It is the number of ways for event A to happen. Sorry, it's getting a little squishy in there. Divided by the total number of outcomes. So you would look at your sample space and say, okay, how many times does event A happen? Just that time, M times. And how many total outcomes are there? N. So it'll again be a fraction. You can write it as a percent or a decimal. Make sure if you're doing this on Math Excel to pay very close attention to the light blue writing to see how they want your answer written. Okay, so on this next one, when you roll a dice, what is the probability of getting a 5? Well, first let's talk about what is our sample space. So if we roll a standard dice, we could get 1, 2, 3, 4, 5, or 6. So this probability though, all I want is a 5. So over here, how many times does 5 occur? Looks like only 1 out of my 1, 2, 3, 4, 5, 6 options. So 1 in 6 would be my probability. You could also write that as 0.167 or 16.7%, depending on what it wants. Okay, now let's make it a little bit more challenging. What is the probability that I roll a 5 or 2? Okay, so this one is going to be a little bit more challenging because of that word or. So when we do this, we're going to start out with P of 5 or 2. So something you're going to need to know is, what does that or mean? When you see the word or in probabilities, that means we will add those probabilities. Okay, so what is the probability of rolling a 5? So this I'll rewrite as the probability of rolling a 5 plus the probability of rolling a 2. Because of that word or, we will add. Or adds. Remember that. So the probability of rolling a 5 we found out up here was 1/6. What's the probability of rolling a 2? Well, I'm using the same sample space, so how many times does 2 occur? It occurs once, and there's still a sample space of 6 options, so we have 1/6 plus 1/6. So when I add those together, I will get 2/6, and I can simplify that to be 1/3, which can simplify to be 0.33, or 33%. 33.3 repeating percent, actually. So let's move on from that. Now let's say we have 2 dice. 2 dice. What is the probability that we get a sum of 5? Okay. So on this one, I am going to have a purple dice, and I'm going to call it die number 1. Okay, how many sides does this dice have? 6. And dice number 2, I am going to have also 6 sides. Okay, notice we want a sum of 5. So, what are the different ways, using your 2 dice, that you can get a sum of 5? Okay, well, let's talk about this. If this dice is a 1, what would I need to add to that to get to 5? Oops, wrong color. 4. If this dice is a 2, what would I need to add to that to get to 5? 3. And if this dice is a 3, what would I need to add to that to get to 5? 4. And if this dice is a 4, what would I need to add to that to get to 5? Who wrote that? 3 plus 2 is 5. 4 plus 1. Sorry, I'm a little bit scatterbrained apparently. So how many ways is there to get a sum of 5? There are 4 ways to get to a sum of 5. Okay, so when we do this, we need to know what is the probability of getting a sum of 5. Come here.